bei sapori.
Hello everyone, welcome back to Bibetech's interview at TuttoFood 2026. Today we are talking about something super exciting, natural biopolymers from bacteria, and now they are revolutionizing the world of food. Today's episode features a special interview with Patrice Volont, business development specialist, and Erwin Lepoudre, sustainability manager from Kaneka. Hello guys and welcome to our stand.
Hi,
Luca.
So Luca, first of all, thank you for giving us the opportunity to talk about Kaneka and our biodegradable polymer Green Planet here at TuttoFood 2026.
So Erwin, who is Kaneka?
Well, Kaneka is an international company with headquarters in Japan. And as a company, we are focused on 4 strategic domains. The domains are quality of life, nutrition, healthcare, and materials. And within these 4 domains, we have multiple product groups, going from conventional polymers, additives, fibers, foams, but as well pharmaceutical intermediates. We are in the food business. We have solar cells, etc. So we have a very broad product portfolio. We have around 11,000 people worldwide and about a turnover of about 5 billion euro. Assets, we are an international company. Beside our production sites in Japan, we have as well a Kaneka North America holding, which is responsible for the Americas, and we have the Kaneka Europe holding in Brussels, which is then responsible mainly for Europe. In Europe, we have as well several production sites. We have in Flanders, Belgium, a site which is on polymers materials. We have a site in Wallonia, Belgium, which is on pharmaceuticals. And we have as well a site in Spain, which is probiotic oriented. I explained already that we have many product groups. So probably then your question, what is now the core competence of Kaneka? Basically, Kaneka has 2 core competences. One is fermentation, and the other one is macromolecular technology and polymerization. And it's basically the combination of these 2 technologies which lead to the new development which we will discuss here today, which is the Green Planet biopolymer.
A lot of science behind. So
Indeed.
Can you explain to us what is Kaneka Green Planet material and the innovation behind it?
Yeah, so it's a biodegradable polymer. Our Green Planet is from the PHA family. It's a PHBH, it's a copolymer. It's a hydroxybutyrate and hydroxyhexanoate, so we can play with the chain. It's a fermentation technology. It's oils, plant oils, or used cooking oil, which we feed to microorganisms, in fact. The microorganisms, they will consume the oils, and they will start to make the polymer inside their body. Once they consume the oil, we will dry them out. We will purify the powder, which we extract from the microorganisms. And this powder, which is done in Japan, so the fermentation step is still done in Japan, we import it into Belgium, and here we will make a compound which can be used in the packaging industry, for instance.
So PHAs means polyhydroxyalkanoates.
Correct.
Very difficult word, right?
Very different.
But that means that it is something produced by bacteria at all.
It's fully produced by bacteria. Correct.
Sounds great. How does the Green Planet differentiate from other biopolymers on market today?
Well, most of the biopolymers currently on the market are synthetic biopolymers. That means they are produced by chemical reactions. So mostly they use bio-based monomers or a combination of bio-based and fossil monomers, and they polymerize them synthetically and come to a biopolymer, which mostly have kind of properties on biodegradability designed in specific environments. So you have biopolymers which are biodegradable only in industrial composting settings. You have biopolymers which is only biodegradable in compost and in soil. And I think the main difference with our material is that we do not use any chemical step. So our whole polymer is produced by fermentation. And because of that, it is as well biodegradable basically in all environments. So it's biodegradable in composts, but is as well biodegradable in open environments, like in soil and in marine environments. We saw biodegradability in marine and soil is mostly only the really natural polymers, so the polymer structures which exist in nature, like cellulose and PHA, what we talk about today.
And what I find cool, and this is the first part of the story that I found really cool, is that these biopolymers come from a bacterial platform. So basically, that means that if I go into nature, I can find some bacteria that naturally produce this material by themselves for their homes. Is that right?
That's right.
That's correct.
Indeed. So like Patrice already said in the beginning, so the PHBH is a part of the microorganism itself. It's a part like we have fats. Microorganisms in nature have PHA in their body, which is necessary for their metabolism. And so it's a part of the nature.
And the second part of the story that I find really cool is that it's about biodegradability, right? So that means that a packaging like this one that is certified industrial compost can be thrown into the organic bin and can biodegrade in the compost facilities. But it's also biodegradable in soil and marine water. This does not mean that people can throw out this material in the open environment, right?
No, that's correct.
But it does mean that this material can find some microorganisms in the open environment that can eventually degrade them, right?
Yeah, that's correct.
Correct.
Correct. That's great. Okay. So what does it mean, composting and compost, right?
Well, maybe before explaining composting step, maybe one step back on biodegradability. What means biodegradability? Basically, biodegradability means that by enzymatic reactivities, the polymer is degraded into CO2, water, and biomass. This is the definition of biodegradability. But biodegradability mostly depends as well on the environment the microorganisms is active. So you have compostability. Compostability basically means biodegradability in an industrial composting installations. That means that you're in a compost in bio wastes and at a higher temperature. So this is an industrial compostability. You have as well home compostability. That means that materials which are home compostable are biodegrading at lower temperatures, even so like in the compost in the garden. And then of course you have as well media like soil and media like marine. So the microorganisms in soil or the microorganisms in marine can as well biodegrade our polymer back to CO2, water and biomass.
And of course, it's not toxic for microorganisms of the soil or organisms of the soil and water, right?
Indeed, I think, and this is of course one of the unique things as well from fermentation. Fermentation is used in the food industry, is a well-known safe technique, so you do not need any hazardous substances like PFAS or any other substances of concern in the production for this type of material.
So we can really say that it is from nature back to nature, right? That's a great. It's a written material. So is Green Planet widely available in Europe today, and how do you see its scalability in the present and in the near future?
So today we have a 20,000 ton fermentation plant in Takasago, Japan. But we have some plans for the coming 10 years. We want to grow to 100,000 metric ton. As Erwin said, we have also a production plant in the US. So there we want also to have a fermentation plant of 20,000 ton. We want to have an additional fermentation plant in Japan to come to 40,000 ton. We want to have one fermentation plant in Malaysia. And of course, for the European market, we really would like to have a fermentation plant also in Belgium, to have a global capacity of 100,000 metric ton over 10 years, let's say.
So that's meaning that Green Planet polyindustrial cannabinoids are already a reality, an industrial reality for food packaging and food industry.
Correct.
Right?
So today we have already the 20,000 metric ton fermentation plant in Japan, which is now being built up, let's say. We need to fill the plant, of course, before we can set up other plants in other countries. Yeah.
And there is much more, because there is a giant we didn't talk before, and that's it, microplastics, right? So Green Planet is microplastic free. Can you explain what scientifically it means?
Yeah, it's correct that microplastics is, let's say, one of the biggest concern nowadays from brand owners and as well from consumers. They see more and more, as you open the newspapers, you see articles about persistent microplastics in nature and out the negative health effects from that. And it's correct that indeed our material is biodegradable in the open environment, is biodegradable in soil, is biodegradable in marine. That means that they will never create any persistent microplastics. If by accident some pieces of your packaging, of your applications are leaking in nature, then of course it will be converted back into CO2, water and biomass.
Basically, we are in front of a material that is produced by bacteria naturally, bio-based, compostable, biodegradable in soil, biodegradable in marine water, microplastic free. But sustainability alone is not enough.
Yeah.
Performances are also critical to make it a reality in industrial context.
Yeah.
So can you tell me something more about the performances of Green Planet material?
So today our material can be used on standard conventional plastic lines. Some parameters you need to check, like temperature, you need to have hot runners. And if you have this all in mind, no problem to use our material on a standard polypropylene or polyolefin line. You can use it as such.
Hot filling, acid pHA, barrier, oxygen barrier. They have a lot of properties that make it similar to polypropylene, right?
Similar to polypropylene.
And you can process in the same technologies as you process normal conventional
fully in
plastics.
the same processing as polypropylene. Yeah.
So that's great. That means that these alternatives to conventional plastics, it's real, it's a present, it can be used in our current technology without any other compromise or excuses, I will say, right?
I think these are basically the three main reasons why we and as well a lot of brand owners and users believe that Kaneka Green Planet's PHBH has a good future. First of all, this is because it's a natural and safe polymer. It's natural, it's made by fermentation. You don't need hazardous elements like PFAS, substances of concern. Second of all is that it has multiple end-of-life options. You can design packaging which is compostable, anaerobic digestible, home compostable, but you can design as well packaging which are recyclable. It fits within the current recycling streams. So you can use the same technologies. And as well, like already said, you don't need huge investment. You can immediately implement it within the current industry with the plastic converting machines like injection molding, tea-dye casting, blown film. You can produce as well the same articles. So I think these are the three reasons, probably the three reasons why this material has really, let's say, a key advantage.
Yeah, it's a food safe material, right? It's food contact safe material, and it's produced by bacteria, right? But we shouldn't be concerned by the fact it's produced by bacteria because it comes from a fermentation process very similar to that one used in the food industry. Is that right?
Correct.
Yes.
Correct.
That's right. Okay. So greenwashing. Greenwashing is one of my greatest concern nowadays. How does Kaneka ensure credible and verifiable environmental claims on Green Planet?
Well, for us, certification and standards are key important. So all materials are certified for home compostability, industrial compostability, biodegradable in soil, biodegradable in seawater. We are certified in Europe by TÜV Austria, we are certified in the US by BPI, we are certified in Japan as well for bio-based. So we have, with TÜV Austria, we are classified as more than 98% bio-based, which is the highest ranking you can achieve. So let's say certification is key important, but as well standards. So you have multiple standards in which you can check our claims. So if we, for example, claim we are never creating any persistent microplastic, then we always refer to the biodegradation criteria under the intentionally added microplastics of REACH, which clearly describe biodegradation criteria. If you fulfill this criteria, you are never seen as a persistent microplastics. So I think, like said, certification and standards are key for backing up all our claims.
And certification means that consumers can know that that material is for sure compostable or biodegradable in open environment, in a specific open environment, and can find that there are some trials, some experimental data, some empiric data, and with a standard protocol, right?
Yeah, and backed up by a third party and backed up by clear labeling to the consumer.
That's great. That's great. So can you share some concrete success stories or application where Green Planet is already delivering some value?
Yeah, I think today we can say that injection molded home compostable coffee capsules is the biggest market today. Of course, thanks to the efforts of Bibetech, we are also present in the food packaging for the pan grattato.
Pan grattato, breadcrumbs.
Pan grattato, so
Breadcrumbs.
we call it our breadcrumbs container. But not only in packaging we are active, also in agricultural fields like protective tree shelters, plant clips, straw production. Unfortunately, not possible in Europe due to the Single-Use Plastics Directive. But for instance, in Japan, we are present at Starbucks. We have a contract with Starbucks. There they have our Green Planet straws today. Cutlery, which is used mainly in US and also in Japan. Also present in the airline industry with fruit bowls, let's say. So we have many applications, and I think we can say that where you use conventional plastics, you should be able to use also PHAs or our Green Planet grades.
Yeah. So regulatory innovation. How do you see the Green Planet in light of the new packaging waste regulation and single-use plastic directive in Europe?
Well, under the packaging and packaging waste regulation, basically all packaging need to be recyclable. But you see that there is as well a specific exemption for compostable type of packagings. So I think this is of course one opening where our Green Planet material can be used. Going back to recyclability, the industry is preparing themselves together with the European Standardization Office, SEN. We are preparing technical specifications how to design packaging from biodegradable plastics like Kaneka biodegradable PHBH, how to design such a packaging so you can recycle them. That will lead as a kind of input as well to the Commission to design, let's say, criteria for recyclability for such type of material. So basically our Green Planet is embedded in product group category 19 of the packaging and packaging waste regulation. And for this product category, the Commission will as well work out the biodegradability, the recyclability towards the future. As said, the industry is preparing themselves. We have already a lot of data which can prove that such a packaging can be sorted out of a mix of other types of packaging by the conventional infrared methods with density separation. We have proven that you can remelt the material into new applications. So such an investigation and data building up is ongoing.
So these natural biopolymers not only are a real alternative to plastics, but are also an opportunity for the bioeconomy, the European bioeconomy, to make it much more strong and robust to perturbation, right? And make the economy much more circular, right?
Yeah, indeed. The Commission has recently published their bioeconomy strategy. As well, the Commission is clearly mentioning that fermentation is a key technology for Europe to become more independent. They as well recognize that bioplastics are the materials for the future. So I think our Green Planet materials clearly fit in that. And we see that now Commission and Europe is preparing additional legislative support for such type of materials to really more endorse materials like Green Planet.
And we all looking forward to see this innovation taking place more and more. So I want to thank you, Patrice and Erwin, to be with us today and making this interview with us. I thank you all the listener. I want to say that Bibetech is sharing values and missions with Kaneka and making Green Planet at the core of our innovation, from food packaging and food applications to agribusiness and blue economy. So we really hope that the Green Planet can find and help us to revolutionize this kind of value chain. Thank you guys for being for us, and thank you for the listener, and see you next time for the next innovation step.